Alrighty, let's look at roots. Probably many of you have heard the term square root. Today we're going to look at square roots and also cubed roots. So just as a refresher, a square root is when you find which two numbers you would have to multiply, which number you can multiply by itself twice to get another number. So the square root of a number is one of its two equal factors. There could be some animal activity here in my loft because the cat is meowing and the rabbit is bouncing around because it rained, so he's in the house and the dog can't handle it. So I just push through my notes. I don't do them over to make them perfect. All right, so a perfect square, Lily, move back. She wants to breathe real heavy in the iPad. A perfect square is a square of integers. Okay, so all of that is a difficult way of saying something that's actually kind of easy. If you look at this example right here, the square root of 36 is 6 because 6 times 6 is 36. So we're looking for that number that when I multiply it times itself, I get the thing that's underneath this square root symbol. So this is a square root symbol. So the square root of 25 is 5 because 5 times 5 gives you 25. The square root of 100 is 10. And then since there's a negative out here, this is like saying, what's the opposite of the square root of 10? So it would be the square root of 100. So we would say negative 10. And then, of course, 7 times 7 gives us 49. All right, so that's perfect squares. But what if you have the square root of something that's not a perfect square that you can't do in your head? Well, we're not going to be using calculators for these, so we're going to learn how to estimate square roots. To estimate a square root, you're going to determine which two perfect squares that number is between. And then once you've done that, you're going to figure out which one it's closest to. So for example, 23 is between the perfect square 16 and the perfect square 25. It's closest to the square root of 25. So that means it's greater than 4, but it is less than 5. It's actually closest to 5. So on the number line, if we were going to graph it, it would be somewhere between 4 and 5, closer to 5, so approximately here. The square root of 7 is between the perfect square 4 and the perfect square 9, and it's closest to the perfect square of 9, so it's somewhere between 2 and 3. I'll make some room. It's bigger than 2. It's less than 3. It's closer to 3. So I'd put that right here on my number line. Okay, that is square roots. Now let's look at cubed roots. Cubed roots are, you probably guessed, a number that you can multiply times itself 3 times to get the number underneath the cubed root symbol. So the cubed root of a number is one of its 3 equal factors. And we can also have perfect cubes. A perfect cube is a cube of integers. Okay, so first let's take a look at this symbol we're using. It looks like the square root symbol, but it has this little 3 right here. That's how you can tell that it's asking for the cube root. So the cube root of 8 is 2 because 2 times 2 times 2, 3 times equals 8. Well, if 2 times 2 times 2 is 8, what would be the cube root of negative 8? You probably guessed that negative 2 times negative 2 times negative 2 is negative 8. Why? Because these two give us a positive 4, and a positive times a negative is going to give us the negative. So you can have a cube root be negative because if you multiply a negative times itself 3 times, you'll actually get a negative. All right, how about for 64? You might just start guessing. Maybe it's 4, maybe it's 8. We know it's not 2, but let's try 4. Let's do like 4 times 4 times 4. Actually, we would do all negatives, wouldn't we? So negative 4 times negative 4 is 16. And 16 times negative 4 is negative 64. Whoops, it wants to make a straight line for me. What about 343? Like, let's say you had no idea. Could you think of, you could look at like what the number ends in and think to yourself, what kinds of numbers would I have to multiply to have a 3 at the end? What kinds of things? So, or if you can't, if it doesn't work that way, because you'd actually have to multiply it by itself 3 times. If it doesn't work that way, go with some numbers you do know. For example, 4 times 4 times 4 is 64. We just learned that in the problem right before. So we know it's bigger than 4. Do we know like 10 times 10 times 10 is 1,000, right? So it's somewhere between 4 and 10. That isn't that many numbers to test out. It's not going to be an even number because if you multiply even numbers times even numbers, you always get even numbers. So if you multiply an even times an even times an even, you're going to get an even. So if it's somewhere between, it's bigger than 4 and smaller than 10, that leaves 5, 6, 7, and 8. And we just said it couldn't be an even. A 5 times 5 times another 5 is going to end in a 5. It's probably 7. So let's see here. 7 times 7 times 7, so this would be 49. Times 7 is 49 times 7. Could we be that lucky? So we get 63. Oh, it's looking good. 28 plus 6 is 34, so it is 7. So there are ways to narrow it down if you don't have the perfect cube memorized. All right, estimating is basically going to be the same approach here. We're going to determine which 2 perfect cube roots it's between, and then see which one it's closest to. So let's list a few of them. Let's do that. Like the cubed root, what did we just do up here? The cubed root of 8 is 2. The cube root of 64, well, let's do the 9. Do you know what 9 is? 3 times 3. 3 times 3 is 9, times another 3 is 27, so that's 3. We did 64 is 4. What would be the 5? 5 times 5 is 25, times another 5 is 125. What would give us 6? 6 times 6 is 36. And then 36 times another 6 would give us 216. So it's good to like just know some of these. We just did 7. So that should get us started. That's just a good list of perfect cubes. So the number 83, the cube root of that, is somewhere between these 2 over here. So it's between the cube root of 64 and the cube root of 125. So it's somewhere between. It's going to be somewhere between 4 and 5. It's closest to the 4. Right? Because the cube root of 64 is 4. So it's about right here. All right, so all of these perfect cubes that we listed could also be negatives, right? So the cube root of negative 60 is between the cube root of negative 27 and the cube root of negative 64, which would be closest to the negative 64, which would be negative 4. So it's somewhere between negative 3 and negative 4, very, very close to negative 4. All right, so that gives you a good intro to both square roots and cube roots and estimating them. Thanks for watching.